Hello, welcome to LearnAid. Today, we'll be attempting question 10 for the 2016 Specialist Maths Exam 1. So, question 10 goes like this. So, solve the differential equation given that y1 is 10 and express y as a function of x. Okay, so now the equation, the differential equation. Okay, now what we need to do here is we first need to rearrange this equation such that we have the y terms together and we want the x terms to be on one side and y terms on the other side. So we can do this by first multiplying both sides by 2 minus y. And this 2 minus y will cancel. And I'll get 2 minus y dy. And then I'll also get 2 minus x squared, 1 over dx equals to 1. So now we need to move this over to the right hand side. So we can do this by multiplying both sides by dx and then divide both sides by square root of 2 minus x squared. Okay, now that we got all the y terms on the left side and all the x terms on the right side, we can now perform integration. Now I'll integrate both sides just like this. Okay, so now just perform your integration. So this will be 2y, y squared over 2. And then over here, for this one, we can refer to our formula sheet, and then we can use this equation. So I'll write that up there for us. So the integration goes like this. If I have 1 over square root a squared minus x squared dx, then I will get sine inverse x over a plus c, given that a is greater than 0. Now, if we look at what we have here, we'll notice that this form fits perfectly with this one. Now, they both have 1, and they both have this minus term. And the a term, a squared is equals to 2, and so therefore a is plus minus 2. Now notice that a is bigger than 0. So that means that a must be 2. So that means that if we perform the integration according to the formula sheet, we'll get sine inverse x over, this should be square root 2. Sine inverse x over square root 2. Now plus c. Okay, now the reason we don't need to plus, well, technically we should plus c on both sides, so we should have a plus c over here as well. But what I'm doing here is basically saying that, well, I'm doing plus c1 over this side and plus c2 over this side, and when I minus them, I'll get c. So this is just a shortcut because everything will work out the same. Now, we are given the initial condition, y1 is 0. This means that when x is 1, y is 0. So we can simply sub this in. So we'll go 0, 0 over 2, and then sine inverse 1 over square root 2 plus c. Now here, this is pi over 4. Because 1 over root 2 is root 2 on 2. So this will be 0, and this will be pi on 4 plus c. So therefore c is negative pi on 4. Okay, now we'll write out the whole equation again. So we'll write out the complete equation with c. So like this, plus, minus pi on 4. Okay, perfect. Now, the last part of the question asks us to express y as a function of x. What that means is that we need to somehow have y on one side, and then we have all the x terms on the right side. Because it is y as a function of x. Okay, now how exactly do we put this into, how do we isolate y, basically? Well, what we can do first is I want to get rid of this bottom 2 term right here, because working with fraction is just very difficult. So I'll multiply both sides by 2. So I'll get 4y minus y squared equals to 2 sine inverse x on square root 2 minus pi on 2. Here, this will be 2. Okay, now I'll do some rearrangement. I'll basically put everything on the same side, and hopefully we can notice a pattern here. And what we can see is that this actually, right here, this is actually ax squared plus bx plus c, isn't it? Where x is basically y, and this is basically a quadratic equation. So what we can do is then use our quadratic formula. So we'll do y equals minus b plus minus b squared minus 4ac over 2a. So that's how we can isolate y, because we identified that is the a squared, and then this is b, and then this is c. And this term is c because there's no y in it. Okay, now let's keep going. So let me just get rid of this, just so we can make some space. But we'll do y equals minus, so b is 4, b squared, which is 16, minus 4 times negative 1, and then multiply by c, which is negative 2 sine inverse x on square root 2 plus pi on 2. Okay, and then all over 2a, and a is negative 1. Now, we can simplify this by doing 16, and then what we'll get here is negative 4 times negative 1 is positive 4. So we'll do positive 4 multiplied by negative 2 sine inverse x over square root 2 plus pi on 2, like this. All over negative 2 again. And then we can further simplify this. And then we'll do 16 plus, my apologies, we can expand the brackets, and we'll get negative 8 sine inverse x on square root 2, and then plus 2 pi. All over negative 2. Okay, how do we finish the question? So we need to check that, because we're given, so from here we can see that y is actually, it actually has 2 functions. So it has the positive side of the function and the negative side of the function. So we need to check that both of these functions have this have the initial condition that is given to us. So what we can do is, since we know that x equals 1, how do we finish the question? So we need to check that, because we're given, so from here we can see that y is actually, it actually has 2 functions. So it has the positive side of the function and the negative side of the function. So we need to check that both of these functions have this have the initial condition that is given to us. So what we can do is, since we know that x equals 1 and y equals 0, we just basically need to sub in x into this, and then we need to work out whether or not y is 0. If both of them gives y equals 0, then perfect. This is your answer. But if only one of them, only the positive or only the negative, gives the solution, then we know that that's actually what the question is, the question wants, and not the other side of the function, because that does not correspond to the initial condition. Then what we can do is basically just go like this. Sub it in. I'll first work with the positive side, and then I'll get 16 minus 8 sine inverse 1 on root 2 plus 2 pi over negative 2. Okay, now let's work with whatever's inside the square root. So we'll get 16 minus 8 multiplied by sine inverse 1 on root 2, like I said before, is pi on 4 plus 2 pi. And then we can simplify this, so we'll get negative 2 pi plus 2 pi, and this will cancel out. So as you can see here, then we'll get negative 4 plus square root of 16 minus 2. And square root of 16 is negative 4 plus 4 over 2. So this will be 0. Okay, so we can confidently say that, okay, so the positive solution must be the function. Now we need to work out the negative side. Okay, so we can confidently say that this is one of the answers, and we need to check the other one. Okay, now I'll get rid of this, and I'll simply get rid of this positive, and I'll switch to negative. And what we'll work out again is that this will be 16 minus 2 pi plus 2 pi over negative 2. And this will cancel out. And we can see here that this will be negative 4 minus negative 4 over negative 2. So this will actually give us positive 4. And we know that y1 should give 0. But here, y1 actually gives 4. So the negative solution must not be the answer. And therefore, the only solution to this question is this. So that's it for me for this video. I hope you find it helpful. Thank you very much.